All right, so starting section 1.4, a little warm-up problem we've got here. This is not anything we haven't seen before. So we'll start off. What is the first step on solving this one? Distribute. Good. So I can go ahead and draw a line. So I have the left half separated from the right half, and then I'm going to start distributing. This 8 is being multiplied by what? X. So 8x. And what else? Times 4. And what is 8 times 4? 32. On the right side, we've got some more distribution. Negative 2 times 3x. Negative 6x. And negative 2 times negative 5. Plus 10. Good. We still have a little bit more. 12 times x. 12x. And 12 times 4. 48. Awesome. Hopefully you made it that far, at least. Our next step is we can do what?
Combine like terms.
Combine like terms, good. We've got to get this down to one variable. So first we'll start with just simplifying that right side, okay? Because we know we have some like terms over there. What are they?
Negative 6 and 12 and 10 and 48.
Good. So negative 6x plus 12x.
6x.
And 10 plus 48.
58.
58. All right, now what? A lot of us did it. Just volunteer. Good. Subtract the 6x from both sides. Move that smaller variable first. Now what? Good. So we're going to subtract 32. Two x equals 26, and the final step. Divide by 2. And x equals 13. So 1.4 is on solving multi-step inequalities. Raise your hand if you've heard of an inequality before. Hopefully, we've talked about them in here already. Okay, the first symbol is greater than. We then have the symbol less than. We also have greater than or equal to. It's got that little line under it. And we have less than or equal to. They look just like that. The types of dots that these include. So a greater than or a less than sign that is not equal to, those are going to have open dots. What about greater than or equal to and less than or equal to?
Closed dots.
Closed dots, good. So they should look just like that. Okay. So when we are graphing inequalities, we graph inequalities on just a basic number line, okay? If the variable is being eaten, then you graph to the right, kind of like an alligator, okay? If the alligator teeth are eating that variable, that means you're going to graph to the right or greater than. If the variable is not being eaten, then you're going to graph to the left. So if it's being pointed at, you would graph to the left, okay? So the first one is x is less than 2. I need to make sure that I have that 2 on my number line. You're welcome to put any extra numbers on there. If you want to put 1 and 3 on there too, you can. I'm okay with you just having 2 though. Then we're going to have an open or a closed dot. Open, and it's going to go to the left or to the right? Left. because x is not being eaten, okay? It's being pointed at, so it's going to go to the left. We then have -1 is less than or equal to y. The first thing I'm going to do on this one is I'm just going to reverse it or reflect it, okay? I like for the variable to be written on the left. It just makes more sense. That's still the same equation, right? Or inequality. Yeah, but it's just written in a prettier way. Y is greater than or equal to -1. So now we're going to go ahead and graph that one. Go ahead and try that. All right, I'm seeing a lot of good answers. So we put that -1 on our number line. Open or closed dot? Closed. And left or right? To the right, because y is greater than or equal to -1. So it is going to be closed dot to the right. The y is being eaten. Questions on that? This all coming back to us now. Okay. When we are solving inequalities, they work just like equations. They're the exact same except for when you divide or multiply by a negative number, you have to flip the sign. So if it's greater than, it's becoming less than. If it was less than, it's going to become greater than. So you're going to flip the sign. We'll try an example. So again, just pretend this was an equation. Don't treat it any different, except for just make sure that you flip the sign if we divide by a negative. So let's try this one. Our first step is to do what? And if you need to draw a line still, you can. Yep, good. Add the 12. So we get 3x is less than 15, good. And next step, by 3. Is that a positive or a negative number? Positive, so do I need to flip the sign? No, leave it alone. So it's just going to be x is less than 15 divided by 3. 5. Okay. Now to graph that one, what number should I put on the middle of my number line? 5. What kind of dot? Open, good. And to the left or to the right? Left. Because it's x is less than, think less than left. Okay. The x is being pointed at, so that means left. Okay, example 4. We're going to start getting into some lengthier ones. But we know how to solve these kind of equations, so these shouldn't be too scary. Okay? If this was an equation, what would be the first step? Distribute. So it's still going to be the first step, okay? Same thing. 5 times 2. 10. And 5 times -x. Great. We still have the 6 being added out front. And we still have the same number on the right. Okay, so we've gotten rid of the parentheses. We don't have any fractions. We now have to, add like terms. Get down to one variable. What are my like terms here on the left? 6 and 10, which becomes? Good. So 16 minus 5x is less than or equal to 41. Okay, now what? Minus 16 on both sides. Great. On the left, it's going to cancel out. And just give us -5x is less than or equal to, what's 41 minus 16? 25. Okay. Now what? By the -5, good. And who remembers what happens here? Flip that sign over. And 25 divided by -5 is -5. So it now is x is greater than or equal to -5. To graph this, what am I doing?
Closed dot to the right.
Okay, closed dot on -5 and to the right. I like it. X is greater than or equal. Good deal. Any questions on example 4? Let's go on to example 5. So we are solving and graphing this one. First step. Distribute 2 times x and 2 times -5. Okay. Now it's time to get this down to one variable. Which one should I move?
That's on the right.
Okay. So we'll subtract 2x on both sides, and I end up with -3 is greater than -10. What do we have there? What happened to my variable? It went away, okay? And I'm left with just a numerical statement. Is that statement true or false? True, okay? So since this is a true statement, the answer to this one is going to be what we call all real numbers. Okay, because -3 is bigger than -10. Don't get confused by that, okay? -3 is closer to 0 on a number line than -10 is. So it is bigger. So that's a true statement. It's all real numbers. And if I were to graph in all real numbers, it's actually just going to be a straight line going to infinity in both directions. So -infinity to infinity. Okay? Questions on that one? Let's try. Go ahead and distribute this one out. And go ahead and get your variables by themselves. See what you get on this one. Okay, what do we do? Okay, and what did you get on that right side? Good. So 7x plus 6 is less than 7x minus 28. Next step. Good. So combine like terms, get down to one variable, minus the 7x. 6 is less than 28. Huh. What happened to my variables on that one? Yeah, they're gone, right? Am I left with a true or a false numerical statement?
False.
False. 6 is not less than -28. Okay, so this is false. Any guesses for what this one's going to be? Yep, no solution. You can write it out or just put that little symbol, the O with the slash through it. And then we've got our special situations, which we just discovered them. A true statement is going to be all real numbers. A false statement is going to be no solution. And make sure you know on these special situations, the variables disappear, okay? Variables disappear, they are gone. Okay. Example 7. All right, this one is quite a bit lengthier, right? Go ahead and try this one. Give it your best go. So the first step, what'd you do? Distribute. What'd you distribute first? Negative what? What'd you say? 2. Yep, the -2, good. So we still have the 8x. We have -2 times 5. Good, and -2 times -x. Ooh, be careful. +2x. Make sure you pay attention to your signs. A negative times a negative is a positive number. Okay. Then on that right side, somebody over here, how do we simplify this? Yeah, distribute the 4. 4 times x.
4x.
And 4 times 9. 36. Plus 6x. Now, what am I doing? Make sure you're fixing it as you go if you messed up. It's okay to make mistakes. Just make sure we correct them. Combine like terms. What are my like terms on the left? 8 and 2. So 10x minus 10 is less than. What are my like terms on the right? Perfect. So 10x plus 36. What'd you do next? Good. Subtract 10x from both sides. Gotta try to get it down to one variable. But our variables disappear. We're left with -10 is less than 36. Think about that. Is -10 less than 36? Yes, it is. So this is going to be all real numbers, that weird looking R with the extra line through it. And if I graph in all real numbers, what's it look like? Yup, infinity to both sides. So going all the way to the left, all the way to the right with arrows on the end. Cool. Questions on number 7? All right. Last one. We're almost done. And then we got the rest of the time to work on our homework. Okay. Don't be scared. Fractions aren't going to kill us, okay? But we're going to kill them. Don't have any parentheses, so I'm good on this one. But I've got a bunch of fractions. What am I going to do about it? How do we kill fractions? The acronym L what? Least common denominator, LCD. Okay, so when we're finding the least common denominator, we've got to look at the denominators that we have, and we've got to find a number that they all go into. Not a number that goes into them, but a number they all go into. What would 3, 8, 24, and 4 all go into? 24, good. And if you can't do that in your head, play around with it. Play around with a calculator, okay? There's nothing wrong with guessing and checking on these. So on the left side, we're multiplying by 24, and we're also multiplying by 24 on the right. Time to distribute it out. So 24 times 1 divided by 3. 24 times 1 divided by 3, she said, was 8. Good. And we still have an A there. Okay, 24 times 1 divided by 8. 3, and this is a negative 3a, correct? Keep the sign, keep the variable. Is greater than, good, 5a, so 24 times 5 divided by 24 is just 5. And then 24 times 3/4. 24 times 3 divided by 4, 18. Questions so far? No? Okay. What's my next step here? Combine like terms. And on the left side, what does that become?
5a.
Is greater than 5a plus 18. Now what? Subtract the 5a on both sides. When I do that, I'm left with just 0 on the right, or on the left, sorry. Because I have nothing left, so it's just 0. Is greater than 18. False. It's not true. So what is it? Good. Do I need to graph that? Nope, I don't. Okay. Any questions? Cool, that's it on notes today.